Hey, welcome back. Today we are going to train a LoRa adapter using Llama 2 as the foundation model. We are going to use the quantized version of Llama 2. And also, that is important to mention, I took some code from different places. All the source will be in the repository. And also the code in the repository is documented, so you can check it out to delve more into the code. And also, the dataset that we will be using is the Databricks dataset, which is a question answering and solving some issues. And that's it. So let's go. So as usual, let's create our code environment, install all of these requirements, and start the project, fire up Git, and that's it. And also, what is nice to remember is that the repository is below in the description, so check it out. For the model, we are going to use Llama 2 with 7 billion parameters and fine-tune it with human feedback. This is the smallest version of Llama 2, but the only one that I can run in my setup. And also, we are going to use the quantized version of Llama, so to make it shorter. Talk a little bit more about LoRa. LoRa is a technique classified as PEFT, which stands for parameter efficient fine-tuning. So the idea here is not to fine-tune the whole model, but just a small part where we can improve the performance without the need of a huge setup to run it. And usually LoRa updates just the embedding matrix of the model. So it creates two matrices and train all the weights in these matrices, multiply them, and merge into the embedding matrix. We have some different path techniques like prompt tuning that build some artificial tokens and improve the performance of the model. We have a lot of different type of LoRa techniques, but today we are going to stand with the usual one. If you are having some problems accessing the model, there is a few things that maybe is causing. First of all, you have to log into Hugging Face, and to do that, you need to take a token from their website and place it in your terminal. The error will give you the way how to do that. Also, if you are showing a 404 error, that means that they can't find the model at Hugging Face, probably because you don't have permission to access it. You have to ask for permission at Hugging Face and also fill out a form at Meta websites. Since I have only 12 GB VRAM, I need to run the quantized version. That is, we convert the data format in a way that we lose a little bit of precision, but we represent it in a smallest version. The library that is responsible for doing that is bits and bytes. So here is the configuration that we are going to use at bits and bytes. And that's it. And we pass it through the model. The model that loads is already quantized. All the LLM models came with specific tokenizer for the model. So maybe if you change a model, we have to change also the tokenizer. And it's actually the algorithm that is responsible for converting words into numbers. So in a way that we can actually map it into a embedding matrix. This specific model have 4096 as max length, and we need to retrieve that from the architecture because we need that information in the future for preprocessing the dataset. The get max length function is responsible for doing that, so we are going to build that function. Finally, I'm going to build a loading function for the LLM and loading also the LoRa adapter. And I'm going to build the sModel function to return the response. And so make a question to the model and it's going to complete it. And it's going to be the answer for the prompt that you make. Here you can check it out how many percent of the weights that we are going to train. It's something around 1% because we have a lot of weights and we can load that in VRAM. We have to load just a few to train it. Here we have the partial function that is used to build a callable method with some parameters already defined. So in this specific case, we have a function, but we have an additional parameter that is the tokenizer, and we want to have just the batch as the parameter. So you're going to use the partial function to predefine the tokenizer as one of the parameters and use that to map the dataset. Here I retrieved a single instance of the data set. It is in the format that I mentioned before in a dictionary. And also I took a prepared instance for the model. That is, we have to tokenize it. And here we have the ID for each token, and that is ready to be inserted in the LLM. Now we are going to train the model. There is a few parameters that you can tweak if you want. And after training the adapter, we are going to save it using the output there variable in a way that we can load it after to make a prediction. Here you can see that the loss came down a little bit, and you're probably going to improve the performance if you let the model train a few more epochs. We trained it for only 20 epochs, but I think that is already enough for this video. To evaluate a LLM, you have some metrics like accuracy, rouge, blood, but the video is already long, so I'm going to only predict using the Llama 2 model and the Llama 2 with LoRa adapter that we trained it, and I'm going to check the results. So here it is. The response from the LoRa adapter is really closer to the response from the dataset. Actually, the first phrase is identical, but it delved a little bit more into the response, but I think that's okay already. We have some different responses, so that means that the LoRa adapter is working on. Also, it's important to remember that you can check it out, the description with the code and also with some of my social medias, my LinkedIn, and that's it. So don't forget to thumbs up and subscribe for the channel if you like it. And if you want, you can contact me through my social medias, and that's it. So thank you so much for your time. Bye bye.